Hi there, thanks for joining me for another video. In this video we'll talk about transformations of linear functions, and we're just going to introduce the idea of transformations, and then in a few subsequent videos we will look more specifically at the different types of transformations. But I think the idea of transformations deserves a video of on its own. And let's start by introducing a term that you may have heard, which is the parent function. And when we look at transformations of functions, we are looking to recognize a whole family of functions that can be generated by one single function, which we call the parent function. In our case, since we're looking at linear functions, the parent function is the simplest form of a linear function. It is just f of x equals x. And in this graph here, you can see that function graphed. As you can see, when x equals 0, we're at the origin where y equals 0. When x equals 5, y equals 5. So basically, f of x is equal to x. It's just the straight line that has a slope of 1 and passes through the origin, which is the point 0, 0. So this is our parent function, and we talk about transformations of this parent function. We're looking to get any other possible linear function from this function. So I'm going to list here and show the different transformations, and then again in subsequent videos we'll look at each one of these separately. So the first, and I guess probably the simplest transformation to understand, is what we call translation. And when we say translation, it means that we're rigidly moving our straight line of a linear function either up or down. So we can move up, sorry, that was down, up or down, right? But we could also move right or left. And in some way, these transformations are basically the same, although we will see that formally we have right and left transformations, which are basically what we call horizontal. And then we have up or down, which are vertical. But essentially, as you can see from this graph here, from this image here, both the up and down, the vertical and the horizontal transformations look the same on the graph. We can also have something called a reflection. When we reflect, what we're doing is we're looking at one of the axes and we are mirroring the, so reflection as in mirror, we are mirroring the graph of the linear function across that axis. So for instance here, we are mirroring this red line here across the x-axis. So every point that is above the x-axis now goes down below the x-axis in the same distance from the x-axis. And you can see this happens also on this side for the negative x's. So basically we're taking this red curve or this red graph line and turning it into this blue one by reflecting across the x-axis. We can also reflect across the y-axis, as you can see on these graphs. So here we're reflecting each point from the positive here to the negative x. While here we went from positive y to negative y, here we're changing the sign of the x value of each ordered pair. And again, we will look at this in more detail in a video dedicated to reflections. Finally, we also have something called stretches or shrinks. And we have two kinds. We can have horizontal or vertical stretches and shrinks. But here again, similar sort of to the up and down or right and left, the horizontal stretch, which means that we're pulling our curve this way is the same as saying that we're getting a vertical shrink because we're moving it that way. So these are similar in that they look the same on the graph, although they are formally performed in a different way. We can also have a vertical stretch. Here again, the red goes up to the blue, or it's a horizontal shrink where we've gone from the red downward to the blue. So again, we can have both horizontal shrinks or vertical stretches, and we will look at these in more detail in subsequent videos. So this was just an introduction to transformations of a linear function. Again, we have translations, we have reflections, and we have stretches and shrinks. And we will go over these in detail.